Using these dill pickle chip data, we have a number of defectives in a given sample, and we see here that the number of drums that's tested for each one of the samples varies. We could go ahead and do the P-chart. Let's just have a look here. We'll do the P-chart using the actual sample size, our number of drums. And let's see what happens. We get this chart, we get variable sample size here, and everything looks fine, nothing is out of control. But in the notes, we've worked out the whether or not we could actually use a constant sample size, and your notes say that we're allowed to do that as long as the variability in the sample size is not more than 20%, and in this case it isn't. And when we look, the average sample size is 519, so I could generate this chart using a sample size of 519. And that being the case, I get this chart. So we could use this one, or we could use this one. Really, from the point of view of statistical software, we would be just as well off using the one that shows the variable sample size. But of course, in the old days when people didn't have a whole lot of access to statistical software, it would have been far easier to use a chart like this, where your lower and upper control limits are constant values. Today, really and truly, we could certainly use this one here with the variable sample size, as there's no issue with the calculations.